All right. So today we're going to talk about our absolute value functions, but in words. So we're going to describe what our graph is going to look like before we even draw it. So today is going to involve using more vocabulary words, but shouldn't be too bad. It is going to be some writing, but it's not horrible. All right. So let's take a look at the inside of these notes. They should look like this. And we're going to talk about each part of our function, meaning our A, H, and K. Alrighty. So each of these pieces does something different, like we've talked about before. But we're also going to use specific words when we talk about what's going to happen to these. So let's start with our A. So A is going to mean it's going to tell us how thin or how wide our function is going to be. So, like we said before in our other notes, if we had a small number, if we had a small number for A, our function would be wider. So, instead of using the word wider, we are going to say it's compressed. So, like, it gets real wide, something like that. That's going to mean that your A is going to be less than 1. And that's going to mean that we use the word compressed. Like it got squished down, like somebody stepped on it, like it got squashed. You're pushing it down to make it flatter. That's what compressed is going to mean, and that's the word we're going to use to describe our graphs. Okay. Other word we're going to use is going to be stretched. So if our graph looks thin like this, or it will look thin, that means that our A is going to be greater than 1. And like I said, we're going to use the word stretched. Like you grabbed it from the top and you just started stretching it out like a rubber band or like silly putty. Like you just are stretching it in 2 different directions. You're making it long and thin and tall. So we stretched our function with an A that is greater than 1. Now these 2 pieces are kind of important for that. So sometimes I know we'll see a fraction and be like, oh, well, that's less than 1. But sometimes we'll get a fraction that's like 4/3. And this is actually bigger than 1. So just be really careful at looking at your numbers. You want to make sure that you have a little number, you have a little number at the top and a bigger number at the bottom. This is less than 1. But if you had like 5/2, this would be greater than 1. So just make sure they're in the right order. Small over big. That will be less than 1. And then if it is equal to 1, then we just don't say anything at all. We're just going to not change that because our parent function or our most basic form of our function started with 1 as its slope. So we're just not going to change it. We don't have any words to describe it if your A is equal to 1. Okay, other special thing about A. If A is negative, that means it's going to point down, no matter how thick or thin it is or compressed or stretched it is. If it points down, that means that your A is negative. So if A is negative, we are going to use the word reflect or reflected to describe it. A is reflected, our function is reflected if A is negative, meaning that it points down. So if any of these things happen, if you have an A less than 1, greater than 1, or an A that is negative, we're going to use one of these words, 1 or 2, because it could also be reflected and stretched at the same time, or reflected and compressed at the same time. That's okay. But it can't be compressed and stretched. So just be careful. But that is all of our words to describe A. Alrighty. So let's take a look at H next. Now H is H. So we know it's going to be opposite no matter what. H is always going to come out the wrong way, or not the way we think it's going to. So if H starts out as a positive in our formula, that means it's actually going to be negative when we put it on the graph. And we need to know that. So if we have an H that is positive, you know that that actually means that once you put it on the graph, it is going to go to the left. And when we say that something is moving to the left or up and down, we say it's translated. And I'll just put that at the bottom here. Translated. And that's going to apply to both our H and our K. These are going to be translated because they're going to slide to either side. So our H is going to be translated to the left if it's positive. And if it's negative, it's going to be translated to the right. Our directions are really important in here, so make sure you know which way is which. Positive goes to the left, negative goes to the right, which is opposite of what we usually do, because H is weird. Okay, so our next and last one is going to be K. K is also going to be translated, because we're sliding it either up or down. K is just K, so we could just take it at face value. If it's positive, it's going to move up. If it's negative, it's going to move down or be translated up or down. Cool. So what we're going to do with these words is basically just write them in a sentence to describe what's happening to our graph. So let's take a look at the next part where we have a few practice questions. I'm going to start with number 1. Okay, number 1. In words, describe the following function. So we're going to use the words that we just had to write down what's going to happen to this function without actually graphing it. So let's see. We need our A, our H, and our K, just like usual. Our A is going to be 3. Our H is going to be -4. And our K will be -3. Okay, so we're going to use those to write a sentence or two about what is going to happen to this function. We're going to start with A first. So thinking back to up here, we had A. These are the words we can use to describe A. All right, so is A less than 1 here? No, this is 3. Okay, is A greater than 1? Yes, 3 is greater than 1, so that's okay. This is the word that we need. It is going to be thin and tall, so it's going to be stretched. When we say this, we're going to say the function is stretched by a factor of 3. That is A. It is going to be stretched by a factor of 3. We use stretched because 3 is bigger than 1. And that's it. That's my only reasoning, is that 3 is bigger than 1. So that's what the word that we're going to use. It's also positive, so we don't need to use reflected. Okay. Now we just need to describe our H and K. So like we said up here, H and K, H and K are both going to be translated. So we're going to say translated. And then you're going to talk about your H first and then your K, just so we could go in order and have it make sense. So let's talk about this H. We have a -4. Okay, looking at my words again. If our H is negative, that means we're going to the right. So we're going to say it's translated to the right 4 units, because that's what it says. Translated to the right 4 units, and because remember your K is also going to be translated. K. Okay, it's -3. So let's take a look at our words. K is negative, so that means we're going down. So it's going to be translated to the right 4 units and down 3 units. And that's our description. The important part here is that you're going to need to say stretched, what direction it's going in for your H, and what direction it's going in for your K. These pieces are important, because otherwise I don't know what you're talking about. So this is a full 2 sentences. That's all we need. It's just a short, brief description of what your graph is going to look like. Okay, so using this, let's try out number 2. So we're going to give you a few minutes. Give this a try. And then we'll come back in a few to talk about this. Pause here. All right, so number 2, let's work through this. In words, describe the following function. Okay, so I still need my A, my H, and my K. Alrighty, so A is going to be -1. Remember, if it's not there, it's a 1. Oops. Alrighty, and our H is going to be +1. And we do not have a K. There is nothing there, so we don't even need to worry about K. We're not even going to include that in our sentence because we don't need to. So we're going to say the function is reflected. It is reflected. Why is it reflected? Because we have this negative sign here. That negative matters because remember, in our descriptions, if A is negative, we need to say that it's reflected to show that it's pointing downwards. Okay, so it's reflected and it's also equal to 1. So remember, when we said A was equal to 1, there was no word to describe that. So we're just going to say that A is reflected and translated. Let's see. So translated, that means that's our H. It's going to slide because we don't have our K, so we don't need to worry about that. But our H is going to do something. So remember, H is opposite. So instead of a plus, think about it as a negative. So we're going to move to the left for this one. It's translated left 1 unit. Cool. That is all that we need for this one. We only have 2 descriptors. Our A was negative and our H moved it. But since we didn't have an A that was greater than or less than 1, we couldn't describe it. Since we don't have a K, we don't describe it. All right. So that is describing our functions in words. Not too bad, fairly short. Just be careful when we practice more that you use the correct wording. That's why we have this nice little organizer here for you. Okay, so we could do that frontwards. We could write the words based on the equation. Now let's go the other way. Based on the words, can we write the equation? So let's take a look at number 3. All right. Find the equation of a function that is reflected, stretched by a factor of 2, is translated to the left 4 units, and down 1 unit. Okay, so our job is to write the equation of the line or the function that looks like this. So I'm going to go through and highlight the important parts here. So we know that it's reflected. That is important. That's a word that we had. It is stretched. And that's going to be by a factor of 2. And it is translated to the left 4 units and down 1 unit. Okay, all of these pieces are going to need to go into this equation. So let's start with reflected. What did reflected mean? Let's go back to the top of those notes. Reflected is under A, and that means that your A is negative. So reflected tells us that A is negative, so I'm going to start with a negative A. All right. It's also going to be stretched by 2. So stretched, that was also a word that was under A. So that's describing our A. That's our slope. Our slope will be 2. All right. It's translated to the left 4 units. Okay. Our H described things that went to the left or to the right. This is going to the left. So remember, that's going to mean that you have a positive 4. Be careful. We're going to put that in here. That's our H. Next one we got is down 1 unit. That refers to our K. It's down, so that means it's going to be a negative 1. And we're just going to subtract that from the end. So now we have our A, our H, and our K all filled in. And we're done here. So these are basically just giving you directions on where to go. You just have to know which letters move which way. You need to know that your A can be reflected, stretched, or compressed. You need to know that H moves to the left or right. And you need to know that K moves up or down. And you need to know that your A goes first, your H goes in the middle, and your K goes last. Okay, so let's take a look at number 4. Once again, we are going to give you a few minutes to work on this, and then we'll come back and talk about it. So pause here. Okay, so let's talk about number 4. Once again, I'm going to go through and highlight the things that are important. So let's see. Find the equation of the function that is compressed by a factor of 1/2 and is translated to the right 3 units. Okay, so I'm going to start out with my blank formula, and then I could just fill stuff in as we go. Alrighty, so let's take a look at the first bit. Compressed by a factor of 1/2. Okay, compressed. That was in our list of A descriptors. So that means our A is going to be 1/2. Okay, then we have right 3 units. Okay, well, right has to be for H. we want the opposite of where it usually goes. So right is usually positive, but we want the opposite of that. So it's going to be -3. And we're going to put that right where our H goes. This description does not describe what K does. It does not say up, it doesn't say up or down or anything like that. So we do not have a K. So we are just going to leave it exactly the way it is. And that's it for that one. All right. So that is all I have for you for the notes for today. They are fairly short, but just make sure that you are following your A, your H, and your K. Use these words to describe them. You want to set it up like I did this one or this one when you're describing. When you're going the opposite way and writing the equation, make sure you just find your A, H, and K and plug them in. That is always your first job with these. Find A, H, and K. All right, so let's move on to some practice. I hope y'all have a good day, and I will see you later. Bye.